Oh, you want an HTTP parser? That's cool. Go write it.
Where do you go work if you know C?
Did you have a job?
Did you have a real job? Yeah.
Did you have a real job?
Welcome back to another episode of Backend Banter. Today, I'm joined by Low Level Learning. How you doing, man?
I'm good. I'm happy to be here. I wanted to apologize again. I'm sorry for pushing this off so far, but I'm happy we finally got together to do this.
The listeners will never know. Like it was.
Yeah,
just...
they don't have to know.
Yeah.
But this should have happened 6 months ago. But here we are.
It's okay. But the thing is, we actually ironed out a bunch of kinks in our production process. So now that the overall quality of the podcast is higher, you're able to come on at a better time, anyways.
Oh, sweet. You guys rolled out the red carpet just in time for me to finally arrive. I love it. That's awesome.
Yeah, exactly. So a lot of my listeners will know who you are, but for those that don't, you've got a YouTube channel. You talk about low level stuff.
Yep.
What does that mean? What do you talk about on your YouTube channel?
Yeah, so my YouTube channel focuses primarily on two things. It's one, low level programming. So when I say low level, I know like C is a high level language compared to the modern ecosystem. I would argue that's not true. So I talk a lot about C and then a lot about assembly, right? So things where, software begins to meet hardware is kind of where I specialize and where I find a lot of like personal passion. And then cybersecurity, right? I think the landscape of cybersecurity, people are getting hacked more and more, it feels like. So I feel like educating people on how that stuff works and how to defend against it is super important. So that's kind of where I push my content in those two directions.
It's funny. I'll say something like, we're going to focus on low level stuff. And when I'm talking to like Python and JavaScript developers, that means C and operating system stuff, right? But like when you talk to embedded engineers or firmware people or electrical engineers, it's like, wait, what are you talking about? C, that's a high level. That's famously like the high level language, right?
Yeah, well, I mean, that's the thing, right? If you look at the time period when C was created, C was literally a high level abstraction for assembly. So when it was invented in 1972 or 73, it was a high level language. But then you compare that to the ecosystem now, where even in like systems programming, you have things like Rust, Zig, and Go. Like it's a fairly low level language in terms of abstractions and the amount of control you actually get directly to memory versus even like Go, or solid language, low level, but you have a garbage collector, which does a lot of stuff like for you without even thinking about it.
Right.
It's an interesting view into, I think, how the times have changed over 50 years and what the word low and high actually means.
When I think about Go and C, it's pretty obvious to me, like C is a lower level language. We don't have this runtime and this garbage collector in between us and what's going on. Is it true to say that C is lower level than Rust or Zig, or are they more kind of on par with C when it comes to how much abstraction is between you and the machine?
That's a good question. I think you could say that C and Zig are on like the same level. Like the whole point of Zig was actually like in a way to be lower level than C, right? Because if you look at like modern C, for example, you have the glibc runtime. And when you do basically anything in C, there are these things called ghost allocations where like if you use the scanf function, for example, to read data in from the user, that's being buffered magically in the background in the heap. So it does an allocation that you're not really aware of. So part of the design of Zig was to not do anything that the developer didn't want to happen, right? So it gives you the finite control that C gives you and also doesn't do stuff without you asking. So you can kind of argue that it's fitting somewhere below C. And then Rust and C, I feel like are at kind of the same level. You could argue Rust is a little bit higher level because of the abstractions it offers and the type system. But they're all like in the same universe with like different caveats, if that makes sense.
Yeah, that does make sense. I mean, it sounds like to me that in any of these languages, you can get kind of down to where you want to go if you want, but like where the language chooses to insert you and like what it chooses to encapsulate.
Right. And what bumpers it kind of puts up too, right? Like I would argue that Zig and Rust are very similar in terms of like the direction they're going in the syntax. But Zig doesn't have the borrow checker, right? You can have two mutable references to the same location in Zig and no one really cares. Whereas Rust, that's the whole point. You can't do that. It tells you explicitly you can't have that access, right? So it's the same level of access, and it just kind of the vision of the language determines the power of it, if that makes sense.
Yeah. When I first started learning to code, it's like 2008, 2009, 2010. The people I was learning from, essentially professors at my local college, like when they said the word web, and I mean, it was probably even more true back then, but like really like what was in their minds was just like HTML, CSS, and PHP, right?
Sure,
Like
right.
just like very simple, because the web was simpler back then. And like it actually probably was more true to say something like, the web is simple. It's like,
Right.
we just...
I agree. When I was learning to code, it was simple. Continue. I apologize.
No, yeah. It's like the web was different back then. You didn't have nearly as many web apps. You had a lot more websites, and
yes,
websites are a lot simpler. It has changed. And like when I was going through my CS degree, I kind of looked at like, front end side of the stack is like the easy side, back end side is the hard side. And
right.
I do still think that it might take just a little bit longer to become proficient on the back end side of the stack, but like it's not...
I agree with that.
It's not like a lot harder. It's like just a little. Like maybe it used to be twice as hard. Now it's like, I don't know.
I think I still maintain the hot take that sometimes the front end feels unnecessarily complicated, where it's like the back end is like hard because you're doing actual engineering and like systems need to talk and be efficient. Whereas front end, sometimes I'm like, why are we doing it that way? I'm like, does that really matter? And then to go back to your point before about the internet back in like the early 2000s, like when I was learning to code, the first thing I wanted to do was like build a website. So me and my buddy Zach, we learned PHP. And like the breakthrough that we had when we learned how to, in PHP, do an SQL query and do select all from users where username equals username and password equals password. That was like, oh my God, we're doing it. And then now if you compare that being like advanced or like the norm to today, it's a different universe in terms of the complexities of frameworks. So things have gotten more complicated for sure. Yeah,
I mean, we started Boot.dev, our web app, on a stack where we've got basically very simple Go CRUD app on the back end. So JSON API written in Go, nice and simple. That remains the simple part of our stack. And then we had a Vue single page application on the front end, and we've already done big migrations on it like 5 times in the last 3 years to take it from vanilla JS to TypeScript, from Vue 2 to Vue 3, and then from Vue 3 into Nuxt, so we can get server-side rendering. And it's just like, it's the hell part of the stack. For, like the Go stuff has hardly changed at all.
I totally agree with that. So my platform level academy, it's the exact same kind of thing you talked about. And so I'm not very good with Go yet, so I'm working on that. But I've been doing Python for a long time. I know that's heresy as well in this community, but I love Python. So the backend is all Django, and same thing. It's a Django CRUD app. That has been very simple. That has not changed. It's a REST API. I expose new endpoints, and like that's it. But the front end, being the React hellscape that it is, I've rewritten that, and I currently have people working on that for me right now multiple times, because again, somehow that is the complicated part as opposed to the actual back end. So I totally feel where you're coming from.
No, we're actually Python enjoyers on this podcast.
Nice.
So Boot.dev, our curriculum, teaches computer science basics in Python and then backend development in Go. We do enjoy Python for what it's for. I want to just take a second and have you tell us a little bit more about Low Level Academy, because I'm sure it's going to come up a couple more times. Then I'll also give you a chance to plug it in at the end.
Yeah. So I maintain a very serious philosophy, both in the world of programming in general. You can be programming in any language, or in the world of cybersecurity, that knowing the fundamentals of how computers work will give you an exponential advantage in learning other systems. And I learned that in college when I started to take my electrical engineering classes and my computer architecture classes. Knowing how the underlying abstractions were likely implemented allowed me to debug much faster. So I made the academy as a way to teach people how to do some of the scarier stuff that I think they tend to avoid because of how like the stigma of C and networking in C and threading in C scares a lot of people. So I wanted to make an approachable course or set of courses to teach people, right? And also have a community around people that are working on the same projects where they can bounce problems off each other and debug. So I made Low Level Academy to do just that. It's literally just courses where I teach people how to first write in C, then write networking code in C, and then write threads in C. And all the while you're doing project-based learning, right? I don't like toy code. I think it gives you the sensation that you've learned something where you haven't fully internalized it, where if you have to go into like full system design and like build out an entire project, you really get the ins and outs of the language. So the Academy does that. And that also has served as a React learning experience for me, because I want to teach C, but I don't know web. So I use that as a way to learn web as well. So it's been kind of a fun kill two birds scenario for me.
Yeah, so like to build the Low Level Academy site, I'm guessing you used React, it sounds like?
Yeah, it's Django in the back, React on the front. And I've learned a lot along the way.
Yeah.
So
that's awesome.
Yeah.
It sounds like we have a pretty similar
fun.
philosophy. Like examples, like foobar examples and like clone type applications, like to-do apps. not a big fan of that way of learning.
Yeah, I agree. I agree.
That makes a lot of sense.
People ask like, oh man, when I learn a language, I keep going back to the tutorials. I feel like I don't learn it. I take a long break from this one language and I feel like I can't memorize the syntax. And I'm like, I really don't think you've thought hard enough about the language. I think you need to sit down, design a system that is just outside of your comfort zone. My go-to is always build an HTTP server, because not only do you have to use the language, you have to use the networking stack of that language, and then also treat all the data you're processing as adversarial, right? Like, you need to treat every person who touches your application like they're trying to hack you. So all those together, I think, forces you to really, really think about the language in a way that internalizes it. So yeah, as opposed to foobar apps where it's like, okay, I opened the file and I parsed the comma separated values. It's like, okay, got it.
Yeah. So I've told this story a bunch of times on the pod, but it's going to keep coming up. So I'm just going to tell it again. When I first started learning web, my first foray was with Django. And the thing that really hamstrung me, I felt like, with my learning was Django does a lot of magical stuff for you. And if you already understand how the web works, like, Django's great. You can get a lot done. You can be really quick and efficient with it. But like, being my first time building a full stack web app with Django, I was just very confused. I'm like, I don't understand like exactly what's happening on my server versus what's getting rendered in my browser. I don't quite understand what this like weird tag CSRF token, CRSF token or whatever. Like I didn't understand like where data was coming in, where it was going. And when I built my first HTTP server in Go, I felt like I actually understood everything because I have this nice little function and I could see the data going in, the data coming out. And that was a big learning moment for me, at least.
Yeah, 100%. One of my favorite features of Django is the ORM, right? Like how you're able to like deal with the objects that feel so seamlessly. But I wouldn't appreciate that unless I knew what SQL in the backend had to be written and know that like, oh my God, if I had to do this by hand, it'd be a huge pain, but the ORM takes care of it for me. And then also when dealing with migration issues, the only way you can debug those is if you know how the schema is likely formed in the database, right? So yeah, having that deeper knowledge enables the abstraction. But I would argue, like inversely, the abstraction itself can be a bit of a hindrance because it works until it doesn't, and then what do you do, right? And it causes a lot of problems.
Off topic, have you? You said you've done a little bit of Go. Have you seen or used the sqlc library yet for databases?
No.
You might really enjoy it. It's pretty cool. It like flips the idea of an ORM like completely in reverse. So your traditional ORM tries to like hide the implementation details of the SQL from you. It like lets you treat everything as an object. And then you'll call something like .save and it'll like do all the magic SQL for you. sqlc is cool because you write raw SQL in SQL files, which is kind of cool because then if it's written in a SQL file, you get like nice syntax highlighting and everything. But then it compiles to essentially Go bindings. So you write your queries in raw SQL and then you run like sqlc generate. And if your SQL is invalid, it'll like yell at you. So you get like this nice type safety with your SQL queries.
That's cool.
So if you're a SQL enjoyer like me, you might like to look at it.
So you enjoy writing the SQL queries. That's interesting. I tried to avoid that as much as possible because when I was getting into web dev like 8 years ago, I was learning how to do like unions and joins and select all as A but this as B, and I was like, if there is a way to not have to deal with this ever, I'm going to do that, and hence the Django ORM, which saves me a lot of time.
What I've found is that, because I definitely used to be an ORM enjoyer, I've found that actually like going back and writing the SQL isn't as much time as I always thought it would be. Like it's actually not as verbose as I thought it would be to do it, and other people might have different experiences. Like the Django ORM famously is really good and also really concise, so it might actually end up, it's definitely more characters to type, but at least in my case it's definitely been worth it because I understand, like at my application level, I understand exactly what query is being run without having to like dig into anything, which has been kind of nice.
And I think selfishly I'm like pushing the blame off to somebody else, like, okay, if it's inefficient, it's the ORM's problem. Whereas if I'm writing the query, you know what I mean? It's like, okay, I actually messed this up. I'm sorry. So finding another person to blame, the ORM, is like super useful for me.
It's not my fault. It's like when you write Python code. It's not my fault it's slow. Like Python's just slow.
It's Python. Come on, what are you going to do?
Okay, I want to switch gears a little bit and talk about C, because it's not every day we have a C expert, a C chat on the pod. And one question I've always had is, how do you debug? Like, what's your workflow when you're working in C? Like, I'm very familiar with workflows in like Go and JavaScript and Python. Mm-hmm. How do you debug like your C code?
Yeah, I mean, the go-to is GDB, so the GNU debugger that gives you, and if you have, so the GNU debugger is an older tool, right? It's not very powerful on its own. I mean, that's not true. It's powerful, but it takes a lot of like dark, like, graybeard elder knowledge to make it work and do its thing. But there are cool wrappers around it. Like one is Gef, one is Binjitsu, one is Pwnlib. They're basically just Python wrappers that you put around GDB. And when you have an issue in C you need to debug, typically the flow is like, generally where it's breaking, you put a breakpoint at that location, and then if you compile your C program with the TAC-G for GDB debug symbols flag, you can get full source view in GDB, and you can just kind of step through the process that's breaking in GDB, right? So if you're having a double free, you can put a breakpoint or even a watch point on a data piece and then have it enumerate all the times that your program stopped at a certain location or wrote to a certain location. And then from there, you can do some kind of critical thinking to figure out what went wrong. But GDB is a go-to. And if your stuff gets really complicated, I know I made a video actually talking against this, but I do like print debugging, right? Like if I'm doing multi-threaded applications, having a simple debug log that says like, hello, I am thread ID X and I'm doing action Y saves you hours of painful debugging in GDB. So that's the workflow at a high level.
I'm a big print debugger.
Okay.
It's like it's definitely my like grug brain, like Go developer that's inside of me. Like I definitely like print debugging. And I found though that how good print debugging is directly proportional to like how quickly you can get into the broken state. So like, for example, if I just like go run my application, it takes, it starts up almost instantly, right? And I can get to like the broken HTTP handler, because I'm usually doing backend development, just by making a curl request, right? So like this is a couple of seconds. So print debugging is really easy. I just like add the print statement, do the thing again. Okay, it's broken there. And I found that like, that's good if it's fast. And the only times I'm reaching for a debugger is when it's like not fast to get into the broken state. Like if I'm going to have to do like 10 minutes of setup, and now I need to be able to like you said, kind of go between lines. Is that how you approach if you're going to print or if you're going to GDB, or is there some other stuff as well?
Yeah, it really depends on the complexity of the application, how complicated I think the bug actually is, and which one is going to get me a faster result. In the world of vulnerability research, what you're actually describing is called a harness, right? So in the case that you have an HTTP server, if you wanted to either fuzz it to find vulnerabilities or debug a vulnerability you've already found, like you're describing, you have to literally shoot a request at it, right? And have that be the input that triggers the bug. But as a developer that the bug is triggered in this specific function. So what if instead you compiled your Go into an intermediate .o elf, right, that exposes the symbol of the function that you know, and instead of wrapping it in the rest of the code of your program, you write a very simple function that puts the input from standard into that function, right? Now you have a very easy way of, I know all the data here is going right to here. I hit this function every time. And then you can do fun things like screaming at it with random data, seeing what falls over. And that whole process is called harnessing and fuzzing. It's a very common technique for vulnerability research. So in the case of debugging an application that you're writing, you could write a harness around that function that is breaking. And that simplifies, I think, the ecosystem of your debugging environment. Instead of having to debug your entire Go application with the runtime and the GC, you can just do this little tiny snippet, I think is another way you could approach it. And I would only recommend going there if you're so lost where like, I don't know how to get to the function in GDB. I can't get print debugging to work. Okay, maybe now we re-engineer the debugging interface. So that's an approach.
Harness. Okay, so I'm new to this term, harnessing. It sounds a lot like a unit test. It's like you're taking out this small part of your application and you're like, what's the difference? Like, is it just that with a harness, you're trying to like simulate something else?
Yeah, so a unit test is effectively what I just said, but it's like to prove that it does do something. This is a unit test interface into that function, but we're going to give it all kinds of data. We're going to prove that it doesn't do something else, right? That it effectively handles all the edge cases. So it's more of a defensive coding idea where instead of a unit test where we say like this function should return, this if this, but otherwise, another value. We are going to figure out a way to pump as much data as we can, as fast as we can, into this function and see what happens when the base case is not given. It's like the inverse of the unit test almost.
Got it. And that's fuzzing, right?
Fuzzing, yep.
What's the failure case? It's like we're going to shove a bunch of random data through a function. And are you mostly like watching memory, like trying to look at allocation patterns? Do you actually care about like the output of the function itself, like the, you know, the number, the string, or do you really just, is it more about the telemetry of like CPU and memory performance?
It's both. It's kind of a performance thing, but it's mainly meant to allow a developer to automatically test all edge cases. Now, like mathematically, that's impossible, right? We're not going, like, if I have a 64-byte buffer, I'm never going to mathematically hit every case of 64 bytes, right? That's like computationally impossible. But what we can do is we can add some constraints to the input we give to the function. And yeah, what we're trying to do is find cases that we didn't think about and make sure that there aren't crashes in the program that we may have already missed, right? So a big project that does this is called OSS Fuzz. It's a project by Google. And effectively what it is all of these big mainstream libraries that everyone uses, like libLZMA is one of them, for example, right? The big topic of the XC backdoor case. When you make commits to libLZMA, there's actually a hook in it that it sends a copy of it out to libossfuzz, where there's literally CI/CD runners that are fuzzing the library, screaming random data at it to make sure that when you give it bad cases, it gracefully fails. It doesn't fail in an error case, in a seg fault, right? Stuff like that. Ones that hackers can take advantage of. So that's fuzzing at a high level. And I think it's a really interesting way to kind of reframe how you code too, because typically we when we write code, we want it to do the thing. We want it to perform this one action, and like that's kind of it.
Happy path.
But from like the defensive coding, kind of a hacker mentality, we also don't want it to fail ungracefully. You know, and we're always looking for ways that it could fail ungracefully, and then fix those bugs.
Got it. So like, okay, so instead of like gracefully exiting with error code 1, right, which is maybe what we want.
We want that to happen
when we scream at it. We want we're just making sure that it's not crashing, filling up with allocating the entire heap we have available.
Yeah.
Got it.
Or like a double free, right? A big one is like the world of buffer overflows and array, access boundary violations is kind of going away. It still happens all the time, but there are protections around things like the stack, right? You have stack canaries and make it pretty hard to violate that. But when you have, dynamic memory like the heap, for example, a very common bug is either a use after free or a double free. And by having a stateful fuzzer that it can, emulate a session in a server that allocs and frees objects, you can find those in a pretty automatic fashion and debug them that way as well.
Okay, tell me about your favorite feature of C. When you leave C and work in any other high-level language, like what's the thing you miss?
Yeah, I mean, so I literally just dealt with this on stream using Zig. So it's not even a high-level language. It's just other languages and ones that are trying to fix the issues of C. I miss my direct access to memory. Like the ability to say like, this is a buffer. Okay, this is a pointer. I point to the buffer and I say thing at index X, right? And do a thing. And I think because mentally, I've spent so much time programming that way, where whenever for example, on stream, I'm writing XXD, right? Like the basic hex dump utility, I'm writing it in Zig. And I know my brain is wired to do that in a certain way in C. I would literally cast part of the buffer. I would printf it with %08x, and that'd be it. We'd be done. But that lack of direct memory access in a way that is meant to be in languages like Zig and Rust immediately makes me have to rethink how I write programs. And it's just wildly infuriating. But it's good because it makes me stretch my boundaries and learn new things.
I was going to say, it's just like, it's the one thing that we've actually been trying to like fix about C forever.
Yes. Exactly. The things that I hate about C are the things that I love about C. It's a very double-edged sword, I guess.
That was going to be my next question, is like, if you could change something about the C language, so you're making not Rust, not Zig, but low levels learning's like third option, what's the big thing you'd change?
I would give C the runtime access checks that Rust has. So like if I have an array in Rust, right, 1024 bytes, if I access a 1025th byte in that array, it'll throw a runtime error.
Okay.
Like if you could give me that in C in a way that's like easy to implement, like just give me like a structure that I implement at runtime, that would save a lot of heartache.
At runtime or compile time?
It's at runtime. It's at runtime.
Would you rather have the check at compile time so you can see the problem in your editor?
Yeah, if it could solve for it at compile time, that would be great. A lot of the time that is difficult because the bugs tend to arise when you have indexes or length values that are derived from network code or of like user controlled runtime code, right? So the traditional example is you have a type length value field, right? You have a serialization format that describes the type of the object, the length of the object, and then the number of bytes after that is the value, TLV. But if the L value is determined by the user and we don't check the L value as it comes off the network, and I copy L, the length by the user, into a static size buffer, that's a bug at runtime that is not detectable at compile time, right? Now, in theory, a code checker or a code analyzer could determine, hey man, you're not validating L, you probably should. And some tools do that, but it's less common. But to the previous question, if C could just tell me at runtime, instead of allowing them to overflow the buffer and give them whatever control that gives them, if it could just, like, once it hits the end of that buffer, gracefully fail, like, cool, that's all I need, done. That gets rid of a significant amount of vulnerabilities in software.
Got it. So it's not about developer experience, which is what like a nice compile time check would give. It's about It's about security. Like, I just wish the C like compiled binary would handle this for me.
And arguably it shouldn't be about developer experience, because this is like where the skill issue argument comes in, where like people are just like, oh, like C is a good language if people just wrote good C. And like, yeah, dude, 100%. That's an awesome piece of advice. Go tell Microsoft, I think the smb.sys driver could use your expertise. Like, when you think like that, you are ignoring the human factors of code, where like C has been around for 50 years. Take that number. That means that arguably there are only like 20 years of people who have like meaningful experience in it. And a lot of those people are retiring. So, and then also consider that there are people who are just now learning language who don't know about cybersecurity. So when you say that just write good code, you are ignoring reality. And we need to be giving languages features that don't give people that kind of power, but they shouldn't feel it, to your point about developer experience, right? It should just be seamless. It should be like, I write the code fails gracefully, I don't have to think about it, because a lot of people don't. And that's why we have so many bugs.
Yeah. So talking about the job market, like, where do C programmers work? Because I know a lot of people from the web world, like, they've never seen a job description for come build my web app in C. Like, where do you go work if you know C?
Yeah, it typically ends up being a lot of firmware engineering type jobs where, you know, you are taking a system, and that it really is one of the only industries remaining aside from like OSs that uses C. So either you're going to be working at Microsoft maintaining Windows, you're going to be an open source maintainer for Linux, or you're going to be a firmware engineer. Now, it tends to be that people who know C know a lot about security if they've been in the industry for a minute, because they've had to encounter it, right? Like, if you write a lot of C, you're going to write buggy code. Bugs are going to get exploited, right? So a lot of people who know the inner workings of lower level stuff in C and assembly can also be good security engineers, right? They can work at a company, and instead of being on the actual forward engineering development side, they can be on the find the bug in the system and write the report to corporate so that they know where to focus their efforts in the future. So C is still alive and well. It's just, I think, not as popular as it once was, because people are migrating to languages like Go and Rust. Not Zig, really. Zig is still pretty young, but it's getting more popular for sure.
Yeah. What about embedded? Like, is, you know, the people who build, I don't even, you know, hardware, remote controls, IoT stuff, is that still being done in C primarily?
100%. Yeah. And I would think the world of network devices in particular, right? So like, if you know C and you want to go work in an embedded company, go find a company that makes routers, right? Go work for Cisco, Juniper, Palo Alto, like any of those companies. The performance requirements on those systems are so high that they need to be written in a language like C, and a lot of times in in assembly, right? Like, just to make it as fast as possible. So those companies, systems that are very, very dependent on the timing of their operations. So think like your industrial control, stuff like that, where you need no shit real-time response to your inputs and outputs or people die, like that kind of stuff.
Yeah.
There has not been enough trust in languages like Rust and Go where they know how they behave, so they still use C. I think actually the White House put out a paper talking about Rust, where one of the requirements by the government for space systems is that it doesn't have a garbage collector, because the garbage collector inherently is non-deterministic. There's no way to formally verify what your code does. Whereas like C, generally you can say like, oh, the code will behave this way. I can map out what's going to happen.
That's fascinating. So was the paper that they will use Rust because no GC?
That was one of the arguments. Yeah. So the paper was basically, it was like the White House trying to come up with a framework for more secure software in the future, right? And they talked about a bunch of different things, like formal verification of software, like basically turning software into a math problem and like being able to prove like, X plus Y equals 4 or whatever, that the code is safe. But then the other one was using memory safe languages, and they gave off a list of languages that they recommend, and Rust was one of them. But they also went on to define the requirements for what they called mission critical systems. And the big example they used was space. And they said that basically because you cannot prove that garbage collected program will operate a certain way, they can't use them. So they didn't say like, oh, Go is bad, don't use Go, but they did say you can't use GCs. Yeah. So it kind of implies,
That also sounds like they're not a fan of what I've been told development will become, which is just that I'll have a big LLM and I'll feed my user inputs into that, and then my outputs come out.
Right.
Does that count as a GC?
Yeah, sure. I mean, I know we have so many doomers that are about like, oh, dev jobs are going away, man. I think like if your job was able to be like taken over by an AI, did you have a job?
Did you have a real job? Yeah.
Did you have a real job? I mean, you have to remember that the LLMs are trained off the internet. The internet is Stack Overflow, and I've seen a lot of bad code and wrong answers on Stack Overflow. So I think AI is one of those things that like, it's a good tool. You should use it to optimize your workflow, help you out. But there needs to be, unless we get to AGI, like there needs to be a human in the loop to verify that that is the correct answer, and that's an operation that's never going to go away.
That makes sense. Okay, I have one more big question that I definitely want to make sure we get to. It has to do with the security side of things, because I know that's where you spend a lot of your time. A big class of bugs, I think, or I should say security vulnerabilities, exist kind of in this side channel attack world, and I think that's like a completely unknown term to a lot of web developers. Can you explain what a side channel attack is?
Yeah, so side channels are super cool. A side channel attack is when something about the information is revealed, but not through exposure of the information itself, right? So a good example to think about is, let's say we have a password checking algorithm, right? I send the password to the system, and what it does is when it checks your password, and it goes over every character, if the character that it's checking is correct, it'll wait 1 second. But if it's not correct, it takes 3 seconds because it has additional processing to do before it tells you that the answer is incorrect, right? Now, it's still going to say the password was incorrect at the end of the operation, right? But because there was a side channel revealed, the timing it took to do this, you could use that to leak out the password, right? You put every character into it for the first character until you wait 3 seconds. Oh, okay, that's the first character in the password. And you just kind of do that until you get the entire password out. The side channel didn't reveal the data itself, but it gave you a property of the data that you could use to leak out the information. So when you think about side channels in real life, a lot of them come out. You have, there actually are timing-based ones that have to do a lot with CPU cache, right? The problem with CPU cache is that an operating system, the whole point of an OS is meant to mitigate process A and process B so they can't talk to each other. But we all share the same cache. So if there's a timing operation that I can read something about the cache of the other process, I could use that to leak information. That was actually the Spectre bug that came out in 2016, where effectively via speculative execution and cache timing, they were able to read all the memory of every process on any CPU anywhere. Just like ta-da,
everything in cache on a CPU.
Everything, every bit of memory on the CPU.
Oh God. Okay.
So me as userland process A running as nobody could read kernel memory, because I could write code that would speculatively execute, meaning the CPU inside the microcode was running it in the future effectively. It was trying to predict where I was going to go. That would load up cache, and I could use other cache timing attacks to read the value of that memory via the cache. Crazy attack. That's a side channel. And another one is power side channeling, right? So when you're doing cryptographic operations like AES, for example, right? The CPU, effectively, when you're doing AES, is just doing a bunch of XOR operations at the end of the day. Now, the order and the values is what makes up AES, but the XOR operation, uses more power than a lot of other operations. So by using this thing called the chip whisperer, you can actually read how much power is being used per cycle and then use that to predict what the key is, right? So by leaking out effectively how much power the CPU is using. So side channels are a crazy world, like literally wizard black magic type stuff, but it's super cool if you learn to understand it.
So the code for like an exploit is like timing things at like the nanosecond level, I would imagine.
So so not so much the nanosecond level. You can actually, I think, go look up the code to do a Spectre attack. It's not that complicated, but effectively you're looking for, is the timing so high that there is a cache miss or a cache hit, right? You're checking for either one, and then you're getting like a bit for bit like blind leak effectively,
which is actually
whether
a pretty
it hits or
big
doesn't hit.
difference, right?
Yeah, exactly. And that's the thing. Like that's the issue with cache is when you miss cache, you get a significant time loss, right? And you're able to detect that in code, and that's how you're able to do the leak, which is really, really amazing. And then same thing with like the power side channels. Like the CPU at idle doesn't use a ton of CPU power, but like a CPU doing like a lot of XOR rounds actually uses a ton of power, and you can use that to kind of side channel out the key. Now, there's also a ton of like statistical probability math in that operation that like I don't know how it works because it's just math that I pretended that doesn't exist, but it's really cool.
Yeah, we like to wave our hands a lot in this podcast. Like implementation details. So I just realized that I have a side channel exploit on Boot.dev for sure. It's not it's not critical, but like maybe it'll be a good example to students who are still kind of like trying to figure out what the hell this means. So when someone submits an assignment on Boot.dev, if they get the answer wrong, or if they get the answer right, but they've already completed that lesson, they'll get a response back from our server like instantaneously, because the HTTP handler is just like, it's a guard clause in a function, and it just like bails immediately. It's like, hey, you got it wrong, or you got it right, but you're already done. If you're getting it right for the first time, it triggers a bunch of events. Like, we need to give you an achievement and give you some XP, right? We need to check if we need to pass off the course. And so the whole HTTP handler actually takes about, 2 or 3 times as long when you get it correct for the first time. So I don't know like how that's helpful to you, but like you could watch the timings and figure out,
I mean, so I think because you're revealing to me whether I got it right or wrong anyway, it's not going to be a side channel where you're revealing other information. But like if for example, I didn't know if I got it right or wrong, like the fact that one took longer than the other definitely reveals something about the nature of the response, that's a side channel. Yeah, 100%.
Yeah, I guess I am just telling you if you got it right or wrong.
No, you're good.
But if it was a different handler, if it was some other handler.
If it was a different handler, yeah, for sure.
Okay, interesting. All right. Tell me a little bit about the tooling that you use to write C. Like, what editor do you use?
Yeah, so this is a hot topic. So I try to use NeoVim. I try to use the tools that are lightweight and fast. I'm like, blah, blah, blah. I'm doing all the Vim motions and stuff. But I find that because I haven't spent the time I need in NeoVim to be a NeoVim wizard, like a lot of us other people on YouTube and Twitch, I use Sublime because I've used it for a long time and it works. Like it does the job. It's fairly lightweight. It's never crashed on me. It doesn't use 12 gigs of RAM like VS Code does. So I use Sublime for an editor. In terms of the tooling, you kind of really have 2 options when you're coding in C, and they're very at opposite ends of the spectrum. You have like GCC. That's it, like flat binary, like you do GCC, you have to make file and it makes a binary. Or opposite end, you have IDEs, like you have Visual Studio Code, or Visual Studio rather, where you have this wrapper with an editor and a built-in debugger, and it has a bunch of linker flags that are like put in for you, and it kind of builds it for you. I lean towards things like GCC, I think because I have trust issues. Maybe, but I want to have the control. I want to know exactly what flags are being given to the program. I want to know what commands are being ran, because I find that when I have problems I need to debug, knowing as much as possible about the build environment and about how the program came to be saves me time, as opposed to if I'm in this big IDE, I'm making a lot of assumptions about what's going on, and I don't like doing that when I'm coding. I really need to know exactly what's happening to reduce the amount of questions I have to as low as possible before I go and run, experiments, right? Which is really all coding is. You're running these micro experiments to figure out, like, did this happen or did this happen? And eventually using that to get to the ground truth.
Some of our students might be familiar with Visual Studio because they thought it was Visual Studio Code, accidentally clicked it, and then had to wait 45 seconds for it to boot up, I think is the typical experience.
Yeah. 100%.
I used Visual Studio in college because we were doing C++, and I didn't understand that there was another option. It was the only way I knew to compile my code. And once I found out that I could just like GCC with a make file, I was like, what have I been doing? Because I spent so much time like debugging my editor, or I should say my IDE configurations.
Yeah, I learned C++ back in the day in Bloodshed. I don't know if anyone knows what that is, but it was like a super old free to download IDE. And yeah, I thought like, oh, to write C++, you must use Bloodshed. There's no other way. And then I learned one day like, oh, dude, there's this program called G++ or GCC, and it's like, you can just use those. They produce the file right here. And like you said before, you don't need to spend an hour debugging the IDE, which a lot of the times, like for example, I wanted to get into game dev and I tried to use lib SDL. I spent so much time trying to get the debug or the header flags in the IDE to include SDL, as opposed to if you just use GCC tac I. Done. It's like, it's right there. It saves you so much time.
Unix philosophy. It's nice when it's all text and flat files.
Yes, exactly. Simple standard IO, and then give me a binary that does one basic thing. Perfect.
I was not expecting Sublime. I feel like every time I talk to a C developer, like that's the Emacs world.
Really? Yeah, so when I was getting into the world of low-level coding in C, my mentor at the time was a nano guy, interestingly enough. So I became...
Those exist?
Right, that's what I said. So he was like big into nano, so I became a nano guy for about 2 years. And then my friend tried to transform me into an Emacs person because Emacs, the operating system, is the best. And then eventually my other friend found Vim, and he's like, dude, Vim is not only cool and better than Emacs and Nano, but you can add all these features and like these extensions. And I found out about like Vim Ricing, where you have like things like NV Chad. And I got into that for a while, but then it's just like, I try to get good with the motions. And when I don't know the motions well, and I don't have the environment set up and I'm getting stuck, I feel very claustrophobic. Like I'm like stuck in like this bundle that I need to like break out of. And when I get into an editor like Sublime, it's very light and easy to use. It's like I can breathe. You know what I mean? I just I type the code. It doesn't yell at me. There's no insert mode or visual mode. I just type it, click, and I go and compile and I test my code.
A lot of people think that I use NeoVim because I don't often bring up that I don't, for obvious reasons.
Right.
But I don't use NeoVim because every time I try to use NeoVim, I'm just too slow. And then I go back. And I understand. I get it. If I put in the time, I'm sure I'd be faster. But I just haven't. And so every time I'm in there, I feel trapped. And
yeah, I feel trapped. And it's one of those things where it's like, I don't have the time to justify doing NeoVim exercises for a long time. I would rather just spend that time in Sublime getting stuff done. You know what I mean?
Yeah.
And same thing, I bought a Moonlander keyboard with the same idea. You know, they looked really cool. I see guys are sitting there coding like this, doing the whole like split keyboard thing. And I tried it and I got to like 20 words per minute typing on monkey type, like the basic English language stuff. And I was like, oh my God, I haven't even learned like the bracket layer. So I just put the thing back in the box and pulled my regular QWERTY keyboard out because I can't personally justify the investment of time when I have actual stuff to do. So just personal preference. And hey, maybe I'll have a free week when I get a week off of work and I'll spend some time and get better at NeoVim and split keyboards, but I'm not there right now.
Yeah, I still respect the hell out of people that do know how to do it. And
100%.
Yeah. Like, I don't think that I've like taken the correct stance in any way, or the incorrect stance, but I'll also say that like philosophically, I'm a default Andy. I like using defaults because defaults usually don't break because it's like the most well-tested thing is like to use the defaults. And I also know that like, you know, when you really get into Vim or NeoVim, it's all about hyper configuring for like your own personal preferences. And I'm like, I don't have that many personal preferences. Like, I like using the defaults.
Right.
So there's some philosophical differences there as well.
Yeah, and when I dev too, like I run Windows bare metal, and then I typically dev in a Linux VM, right? So it's like VMs are mildly ephemeral. They tend to die for like no reason. So what I don't like doing is spending a lot of time like ricing out my NeoVim, and then like the VM dies, and it's like, fuck, okay, now I got used to that. I have to go rebuild it again, spend another 2 hours installing all these packages. I would rather just use the defaults that happen right there, that I not only don't need to spend time with, I'm also very comfortable with. So I totally agree.
Okay, a couple more questions that I think will be interesting to web people that are new to C.
Sweet.
How do you deal with the lack of a package manager? Most web frameworks have like,
Mhm.
or I shouldn't even say frameworks. Most web languages have a package manager. Go's got go get, Node's got npm. What do you do in C?
Yeah, that's funny. In C, a lot of the time the answer is you implement it yourself. Like, oh, you want an HTTP parser? That's cool. Go write it. Oh, you want like a TLV structure parser? Cool. You have to go write that. That's part of the answer. The other answer is there are libraries written for things. Like no one in their right mind is going to go like implement compression like gzip, or no one's going to go implement how to do an SSH or an SSL key exchange, right? All of those are done in libraries. And I would say that like the documentation for those languages are very verbose. And if you install the package, you get the man pages. And because C is such a simple language, typically the man page is all you need. Like if you typed like man SSL write right now, like how to do a write over an SSL context socket, like it would tell you all you need to do. So when you find the right library, it's easy, but sometimes finding the right library is the hard part. So,
and like getting the library, there's not like a central repository to install from. Like, do you just go get the code and put it somewhere?
So if you're lucky, you're on an OS that has it in apt or yum or whatever like the repo is, right? So if you want to use OpenSSL, right, you do sudo apt install libssl tacdev, right? Like libssl gets you the actual .so file, the shared object. Tacdev gets you the source code you can compile in, right, or the header files. So that's most of the time. If you're lucky, you're writing a project that depends on libraries that are actively maintained. They're being committed to apt or to yum. You install the dev repository version and you can just pound include openssl.h. Done. If you're doing some weirder like ephemeral stuff or stuff that's like kind of off the beaten path, go find it on GitHub and you can go download it and make the shared object yourself. Other than that, yeah, there aside from apt and like well-known Git repos, there really aren't good solutions.
I didn't realize that like apt or maybe even brew if you're on a Mac. I'm not sure. I haven't done C development on Mac, but like that is your package manager. Like it also
100%.
is used to install command line tools, but also used to install dependencies.
Yeah, like if you want to do CDev and you want to like cross compile to another CPU architecture, how are you going to do that? You're going to sudo apt install gcc dac the architecture for the target, right? For like if you're compiling for Raspberry Pi, you're going to gcc tac arm, and like if you want to install the lzma header files, libLZMA tac dev, so it's all there in apt. So yeah, I guess you could say that because C in Linux is GNUC, the glibc library, and the apt repo is Linux's package manager. Like through some weird transitive property math, like it's also C's package manager. That's not like a great answer, but it's the answer we got.
How do you tag? Because like I'm guessing you don't check in those dependencies to like source control. Do you just like list them in a README or something?
Yeah, literally the answer is like you have if you're a good boy and you're writing code you want other people to use, you're gonna have like a setup shell script, or you're gonna have like a deps shell script. Then you'll run it. It's like deps.sh, and all it'll do is sudo apt install all the dev repositories that like your project depends on. And so back to like the XZ backdoor, this question of trust. When you're downloading a lot of C projects, you end up running a lot of shell scripts that other people write that you're kind of just like hoping don't do evil stuff.
Yeah.
So yeah, man, that's pretty much it. It's like there's no requirements.txt or package.json file in C. It's like hope the guy told you what it was. Otherwise, you're literally going to go comb through the headers and see what's in there.
A lot of one of my favorite things about Go is the idea of a statically compiled binary. And I know when you're doing low-level stuff, that's obviously like a bad thing because you get this like really bloated binary. It's like copied all of the logic into the binary. But the nice thing about a statically compiled binary is you don't have to worry about what's on the host machine when you run it. How do you feel? How do you feel about statically compiled binaries and dynamic libraries?
I think the statically compiled binaries thing mattered a lot more in a world where like memory was very expensive. But as memory has gotten cheaper, it matters less and less. And I would argue that especially like systems like the way that the glibc versioning system is set up, it creates more issues than it solves, I think, because Go code is notorious for being very portable, right? Like as long as you adhere to the syscall ABI of the system, like the Go code will go anywhere. Whereas C code, like there are certain exports that libraries export that like you have to have. Like if this version depends on glibc 231, it may not work on a system with glibc 218. You know what I mean? It's just like you can't just copy and paste a C file from here to here, or a C binary from here to here. Whereas Go, because it's statically compiled, that's not even a question. So I think to answer the question, it's a good thing. It saves a lot of heartache. It just depends what your use case is. Now, if I'm on an embedded system where I only have like 256 megs of flash, for example, I'm going to lean statically compiled. I'm going to lean dynamic objects, right? But if I'm on a modern Ubuntu 2204 with a terabyte of disk space, like, yeah, dude, ship me a Go binary with no libraries. That's awesome. I love that. For a
personal laptop, personal desktop use, would you prefer a statically compiled binary, or would you prefer a dynamically compiled binary?
I think static. I think static. It just guarantees to me that the code will be portable across multiple versions of that OS.
Got it.
Whereas if it depended on a specific shared object version, that's not always a guarantee.
So really the only time you care, where you would prefer to have a dynamically compiled binary, a binary that depends on things dynamically, is if you're extremely resource constrained.
Yeah, exactly.
Yeah, I think I'm the same way. And yeah, like that's been my favorite thing about Go and Go on the back end, is like I'm never deploying on a server that doesn't have, at least like 500 megabytes of RAM, like whatever,
Right.
whatever I need to run my thing. But cool. Well, this has been so much fun. Thanks for taking the time to come on, man. Yeah, man. Of course. Thanks for having me. I do want to apologize again that it took so long, but I'm happy to be here and spread the philosophy of the low level. That's what we do here. Yeah, I appreciate it. No, so I also want you to just take a second and plug all your stuff. Where can people find you online? And just anything you want people to be aware of that you're doing. Sweet, yeah. So I'm on YouTube, youtube.com/c/low-level-learning. I'm on Twitch, twitch.tv/low-level-learning. I also have a course website to learn languages like C and assembly, Low Level Academy. And if you want to hang out with me on any of those platforms, I do YouTube videos typically once a week, and I'm trying to stream more often, once a week at best, but we'll see how that goes. But that's where I'm at, man. Fantastic. Okay, talk to you later, man. All right, thanks for having me. Appreciate it. See ya.